Okay, let's give you guys some more practice. So find a way to represent sine of x as a Maclaurin series centered at x equals 0. So as a reminder, we've always started out by listing this. So you've got your x to the power of 1, 2, 3, 4, 5, all the way to infinity. We would then differentiate each step of the way, and then for our function, this time around it would be sine of x, because we're trying to find a representation of sine of x. So we would then differentiate it each step of the way. We would then demand the derivative of this to match up with the derivative of this, the second derivative to match up with the second derivative, and so on. If you were to follow this whole process, it would lead you to this formula. So rather than having to do this whole thing here, just jump straight to the formula. Okay, and then you can, once you've got it in this form, you can always tidy up by representing it as a summation. So find a way to represent sine of x as a Maclaurin series centered at x equals 0. So here's a formula. So just make use of this formula. So press pause and have a go. Okay, so to do this, looking at this formula here, we need the first derivative. So starting out with our original function, differentiate it once. That will then give us our first derivative. Well, we need to evaluate the first derivative at 0. So put 0 into here. So that will be cos of 0 will be 1. So this block here will be 1. This block here will be 1. And then looking at the original function. So this is our original function here. Evaluated at 0, so put 0 into here. Sine of 0 will be 0. So this block will be 0. Okay, so hang on, let me tally this up. So this will be 0. This will be 1. And then now looking at this, we need to look at the second derivative. So looking at the second derivative, evaluated at 0, so put 0 into here. Sine of 0 would be 0 minus 0 is 0. 0 divided by 2, that would be 0. So this whole thing here will be 0. And then looking at the third derivative, so this is our third derivative, evaluate it at x equals 0. So put it into here. So cos of 0 will be 1, negative 1. So this thing here will be negative 1. So that would then be this. Hang on, negative 1, remember. So that would be negative 1. So this block here would be 1. So it would be 1 over 3 factorial. Okay, and then so that would be this. That would be minus 1 1 3 factorial x to the power of 3 x to the power of 3. And then for this one here, we would look at the fourth derivative. So looking at the fourth derivative, evaluate it at 0. So sine of 0 would be 0. So this whole thing here would be 0. So we can ignore the 4, x to the power 4. That's why there's no x to the power 4 here. But the next one will be us looking at the fifth derivative. Well, the fifth derivative, we would need to evaluate it at 0. So we put 0 into here. This will be 1. So it would be 1 over 5 factorial x to the power 5. And then if you follow this whole thing here, it will lead you to this. Okay, now we need to put this into the summation form. So to put it into the summation form, if you look at this here, you put it into the summation form. Here you've got x to the power 3, so it goes up. These are all odd numbers. So when you think about odd numbers, you have to write as this plus 1. So if you have something that goes up in even numbers, then it will be 2n, x to the power 2n. But here here it goes up in odd numbers. So write as 2n plus 1. And then if you look at this, you've got plus, minus, plus, minus, plus, and so on. So it's alternating. So you know somewhere in here you're going to have minus 1 to the power of n, or maybe n plus 1. You haven't decided yet. And then if you look at this here, here you've got 1 factorial, 3 factorial, 5 factorial. So somewhere in this summation, you should have n. Sorry, all these are odd numbers. So you should have 2n plus 1 factorial. So to rewrite this in summation, you know it's going to contain this. You know it's going to contain negative 1 to the power of n. Could be n or n plus 1. We haven't decided yet. But our first term should be a positive. Somehow you've got to create a positive. And somewhere in here you should have 2n plus 1 factorial. Well, if you think about it, if you rewrite it, it will lead you to this. So this here is your final answer. Okay.